Hi everyone. I wanted to give a couple comments on the challenge problem on homework set 6. This is a case where a spring-loaded truck is being shot across the floor onto a circular loop-the-loop. And this particular truck doesn't have a lot of energy. In fact, we know it gets shot up all the way up to here and then falls off the track at point A, so splat. There's a couple key points to this problem, but this is straight up an energy problem. There's no external work, so we ought to be able to write down that the final energy in the system minus the initial energy in the system is going to be 0. The other thing that you can write down with this is the condition for falling off the track here at point A. And the easiest thing to see here is if I go ahead and I have to do a little construction here. That means I am going to make up a variable in the problem. I'm going to call that angle theta. And then when I get all said and done, what I need to do is take that angle theta and eliminate it from the problem and express it in terms of r's and so forth. So what I can do here is go ahead and say at point A, we have a free body diagram that looks like this. The condition for, the diagram doesn't look like that. The diagram looks a whole lot more like this. MG. That's it. Kind of boring. And the reason is that when the truck falls off the wheel, the normal force is 0. And in fact, that's the problem here, is that eventually this weight component can't provide the required centripetal acceleration to keep it on the circular track. So we get that the normal force equals 0 at this point. Then I can go ahead and figure out at that point, if this is theta, this has got to be 180 degrees minus theta. And I know that that distance there, this mg, will project a component here. And so I know that mg times the, looks like a cosine of 180 degrees minus theta, well, that has to be divided by m, has to provide me with my centripetal acceleration, which is going to be v squared over the radius of the loop. So I can do a little canceling, and everything looks pretty at this point. So this sets up the basics here. Where am I going to get v squared from? Well, that's straight up energy. I know that the final energy in this case is going to be some potential energy, mg times h, plus some kinetic energy, 1/2 mv squared, and then there's no spring energy anymore. It got dissipated to actually shoot, or it transferred into the potential and the kinetic. So that's my E final. My E initial here is going to be, well, I have no spring energy, or no gravitational potential energy. I start from rest, so this is UG equals 0. That says that K equals 0. And then I finally have the potential energy stored in the spring, 1/2 K x squared. And I know that all that is going to be, that difference is going to be equal to 0. And I contend between this, and the powers of trigonometry, you'll be able to put this all together and find out what the problem's asking for. So good luck, and have a great weekend.